Large language models, LLMs, represent a significant leap in artificial intelligence, showcasing the ability to decipher complex language patterns and generate human-like text. These advanced AI systems are trained on massive data sets that encompass a variety of textual sources such as research papers, articles, and manuals. By processing vast amounts of information, LLMs create an intricate web of connections, much like the neurons in a human brain, forming a rich data lake of textual knowledge. The training process of an LLM is often likened to a black box. Inputs are transformed into outcomes through sophisticated algorithms. Inside this brain, rather than storing exact copies of documents, the AI develops a model that identifies relationships between words, ideas, and patterns. This process hinges on statistical inferences and learned behaviors, allowing the model to produce logical responses. However, it's crucial to understand that LLMs do not possess true comprehension or memory in the human sense. They merely predict outcomes based on previously encountered data, emulating certain aspects of cognitive thought. When interacting with an LLM, users provide prompts or questions that prompt the AI to generate responses. The model evaluates its accumulated knowledge and uses learned patterns to yield the most probable answer. The pivotal point to recognize is that the variability of these outputs is dictated by the breadth and depth of the training data. Users must acknowledge that such models lack genuine understanding and the quality of responses can fluctuate significantly. A potential risk arises at the intersection of data security and system architecture, particularly within platforms that utilize LLM technology. The most pressing concern regarding data security is not the complexity of the language model itself, but rather the systems that host or connect to it. Sensitive information can be inadvertently exposed when users submit prompts containing confidential data. This data leakage risk escalates in environments with weak access controls or poor system design. For instance, in a cross-user data leak scenario, a system flaw might cause a confidential prompt from one user to inadvertently appear in another user's output, emphasizing the serious implications of data mishandling. The key takeaway is that to safeguard sensitive information, organizations must prioritize securing the systems managing user prompts and access and ensure their staff understand safe and secure approaches for AI use. For individuals, minor leaks might seem insignificant, but in business or regulated environments, it's paramount to restrict queries that could put proprietary data at risk. Remember, protecting your crown jewels is the number one rule. The essential and confidential information should always be the foremost concern when interacting with any LLM platform.